Oh, hello guys, I am Chaitanya Yadav and I'm starting a project called Content Factory Agent. Before I move towards the main video, I would like to tell you about myself. I'm a recent graduate and I want to become a AI engineer. And I'm starting this Devlog series to, log my project and keep track of my progresses, and it helps with my accountability. So enough about myself and let's go. So, my main idea is to make a content factory agent, which is a fully autonomous AI agent that makes YT shorts or Instagram reels from a single prompt. The AI agent will take care of the following. When I give the prompt, it will start preparing a script. It will write the whole script in a very detailed manner. Then it will divide the script into prompts for media generation, reels will have shorts or clips. So it will divide the script into clips, like another short form of those shorts, and those prompts will be used for media generation. Oh, media generation. Anyways, so after dividing those scripts into clips, it will queue jobs for media generation, and when the media generation is completed, it will save the media assets into the local directory. To give you an overview of the main architecture, here the content factory is divided into three main components. First is the agent orchestration layer, which I am developing this in LangGraph. Then the media generation tools, which are actually comfyUI workflows. I've actually make few of the workflows here. This one is video generation. This one is for image generation, and I'm using open source models for these generation, which are downloaded from huggingface. Uh, and my setup is actually MacBook Air M4 16 GB unified memory. So I'm kind of bottlenecked here on the resources. So I'm not using any heavyweight models. These are really lightweight models. This one is a Flux Schnell Q4 quantized GGUF. And for the video generation, I'm using LTXV 2 billion parameters 0.98 version. So these are lightweight models which can run on my device. Make sure to check the compatibility of your device before using these models. So moving forward with the project. So the media generation tools from the comfyUI workflows, and after the generation of media, I'll use an AI video editor, which is a manual process, but it can be used with the AI agent also, which is my future scope of this project. But for now, I will stitch the videos manually. Moving further into the architecture, the user will give a prompt, and a LangGraph agent or a LangGraph workflow will trigger. So the first step will be to generate the script. The second step will be to divide the clips. Third one will be to generate media assets for each clip, and then report the user when finished. So this is the overview of the architecture. I hope you got the idea. So let's move into the code now. Here, I'll start with the media generation API. So this is a class I've made to manage all the workflow communication and the communication with the comfyUI backend. Here, the comfyUI service runs on this base URL. The video generation function is stubbed for now, but I have implemented the image generation. It uses this workflow for the media generation, which I've shown you earlier. I will show you again. This one. This workflow is saved in the JSON format, and I'm using this workflow to generate the images via a client. So in this function, I load the workflow and set the prompt and seeds. Seed is actually just a random number which we use to improve the performance of the generation. Then I request the comfyUI backend, and it responds with a prompt ID, which we will use for the further process. And before moving further, I want to tell you that when we send a request to a comfyUI backend, it does not give you the result immediately, because image generation and media generation takes quite a time. So instead, it gives you an ID from which you can use to track it. And for that purpose, I have made a poll function, uh, which will be used to poll our queued job. We will use our previous prompt ID to poll the job, and then we will get the status of the job. If the job is currently running, it will propagate this response forward, and when the job is completed, it will return the outputs. The outputs of this function still does not contain the actual image. It only contains the details of that image, like where it is saved or other metadata. To actually get the image, I have implemented this function, which take the arguments such as file name, subfolder, or file type. Here we will request that media through this URL/view. We will send these as the params, and after that we create the directory and path and store it in that. And after that, we will just return the path for now. This is a very starting point of this project, and I have just started implementing this project. So this is a very beginning stage of the project. If it does not seem much big for now, then let's move on to the tools, the actual tools that will be used by the agent. The class that I've created earlier, I'm using that as a base class, and here I'm creating the tool wrappers so that I can handle the error only inside the tools, so that no main errors are propagated and crashes the application. So the queueGenerateImage tool will take the same arguments as the class method, and we will just call the class method in the tool wrapper and propagate the response. The same is for the polling function and the save media asset function. Now moving on to the main graph that I've made for now. I've made a very big generic beginner graph, which is just an image generation workflow. So in LangGraph, if you are familiar with the LangGraph, it's actually a graph API for creating AI agents, and we create a workflow graph where we where we pass the state object through the nodes and edges. So I've created an image job state, uh, which inherits from the typed dict, and I've created some stages here. Topic, which will be the main prompt for which the media has to be generated. The prompt, it will contain the generated prompt by the AI. This is the prompt ID, which we'll get after submitting the job. This is the job status, which we'll get from the polling method, and this is the files. This will save the actual file output, and this is the save path we will get after saving that file into a directory. And this is a error state, which will be populated if there are any errors. So in LangGraph, every node is created by creating a function. You make a function, you implement a function that accepts your state argument and returns a dict. So the first node is to generate prompt node. For now, I've used a template prompt to test the graph. Actually, I'll implement the LLM agent here in the production version. This one is the submit image job. It will request the backend to generate the images, and here we will update the state with the prompt ID and the status. The third node is the polling job. Its job will be to poll the backend to get the updated status. If the job is completed, we will update the state with the completed status and the files and the save path, which is a local path for now. After that, we will save the image into the local directory using our save media asset tool. And this is a conditional node which will reiterate or run the loop again if the job is not completed. You will understand this better in the graph. Here I'll initialize the graph with my state above which I've created. I've added all the nodes. Now if you look at the graph starts from a very special node provided by the LangGraph, which is start node. This node starts the actual graph, and it connects to your very first node, in my case, which is generate prompt. Then I add an edge between generate prompt and submit queue, because after generating the prompt, the next step is to submit the media generation job. After the media generation job, it will poll the backend, and after the polling, here comes the conditional edge. So the first argument is the node from where the conditional edges should go. So polling job will look the result of this function, should continue polling, which I've shown you above. If the job status is completed, it will return save, or otherwise it will return wait and repoll. So if the response is save, it will move towards the save asset node, which is our last node. If the response is wait and repoll, it will move towards the wait node. And here is the wait node. It does nothing, just sleeps for 30 seconds, because we don't want to keep continuing sending requests to the backend. So after the save asset, if we go to the wait poll, it is necessary to add an edge which will return us to the polling job node, so that it can create a loop. But after, when the save is returned from the conditional edges, it will move towards the save asset node, and the save asset node is connected to another specialized node by the LangGraph, which is the end, and it marks the end of the LangGraph agent. Here I've just compiled the graph, and oh, this should not be for you. So to test this graph, I'll call this graph in front of you. Generate an image of an astronaut walking on the surface of Mars following the Mars rover. This is just a random prompt to test the program. I have actually tested the program many times, and it was really irritating time when I was debugging and squashing the errors. Earlier I have made very silly errors, like you know key errors, and very basic errors. Anyways, errors are not important. Let me just run it. So it was on the generate node, then it moved to the submit job node, then it goes to the polling node. Now I've told you that the media is not completed, that therefore the job has returned the wait and repoll reply, and therefore it goes to the wait node, where it is waiting for 30 seconds, and then it will go to the next node, which is the poll job node. It will return to this node again, and it will again check if the status is completed, then it will move forward with the results. Here it is waiting, and here the comfyUI backend is working to generate the image, which is going to take time. While this media is generating, I would like to show you my setup. This is actually an MCP server which connects this project to the cloud. So the cloud can actually read files in my project and suggest me better on how to move forward with the projects and debugging steps. And I have been debugging with the cloud from this tool. I made this tool by myself, for myself, and it has been really helpful for me a lot. Well, this one is taking a lot of time. Uh, Only if I had a very powerful GPU, this would have taken seconds. But for a 16 GB Mac, it still gives pretty good results. And if anyone else is looking forward to running on a very limited hardware capacity, you can still work with the lightweight models. To show you my consumption, it can run on a 16 GB memory, but it uses a lot of swap, which is actually using SSD as memory, and it generates medium to low memory pressure, but sometimes very high when I'm using video generation models. And it's currently using 12.06 GB of memory for the image generation models. Hmm. The comfyUI backend is done. It has generated the image, and it's done in 281 seconds, which is nearly 4 minutes. It's still on waiting. On its next poll, it will move towards the final node. Here we have gotten the result, and the result, it might looks like gibberish to you, but it's actually the state that we created in the beginning. And as you can see, in the save path key, there is our asset, and to show you that asset, it's here. So this is just a very beginner workflow. There is no AI involved right now, but it will be later connected to an agent, where agent will control the generation, polling, generation of scripts, etc. If you like this video, or if you like the project, I will post more videos about the project and will keep you updated. uh, until then, thank you for watching this video, and see you in the next one.